Hi all, so today I came across something that I wanted to entertain as a quick project, and I thought I'd share the experience of how I went about achieving this using free online software. In case you're wondering what this is, it's a Tesla key fob for Tesla cars. Tesla vehicles sometimes come with a key fob, and previous models had a little keyring fitted and molded into the case of the fob. However, these days with the revised version, the fob comes completely smooth and there's no such thing. I found that the rubber one that came with the key would often loosen, especially in the heat in summer, and the fob would just slip out. There are plenty of alternatives on Amazon for such key holders, and I could have just bought one, but where would the fun be in that? Since I have a printer capable of printing TPU, I thought I'd give it a try. Therefore, I hopped onto Amazon to grab myself some TPU. Zyro is one of my favorite brands of PLA, and I thought I'd give it a try for their TPU. So TPU is a flexible material halfway between plastic and rubber. Suffice to know that it would be flexible enough for the purpose of this project. So I'm a Linux user, and from time to time I use Mac as well. But I've been predominantly a Linux user for a couple of decades now. Therefore, my preferred CAD solution is Onshape. Onshape is an online CAD software package that can be easily used to design various items. So it's entirely online. You can use it on any computer. You don't need to install anything on your machine. You just point your browser to it and log into your account. Suggest signing up for it if you don't already have an account. And once you're there, you can create CAD models very easily. So once you log into your account, you're greeted with a list of your projects, and as you can see, your free subscription tier allows you to have only public projects. That means that anyone can see them. If you want to have more private projects that you don't want shared with the world, just try the professional subscription. So we're going to be looking at the Tesla key fob project that I have here. And this is basically the end result. This is what we want to achieve in the end, and I'll go ahead and explain how I managed to get this into the CAD software. And let's jump back into the real item and we'll have a look. So I'm pretty sure there are different ways of doing this, but the approach I took was to take a few key measurements at some vague different intervals along the body of the key fob, and just so that I can create some kind of rectangles that I can link up in the end. And we'll use some of the CAD features to kind of create the curves and the smoothness around the key, but just here taking a few dimensions, how long it is from the nose to maybe the front arches, to essentially the height of the maximum height of the key fob, and taking some rough dimensions, mainly rectangles along the body of the key fob, and we'll just take those values and key them into some sketches in Onshape, and hopefully that'll give us a better idea of what's going on. Right, so back in the CAD model, the one thing I want to show you first is that at different points of the physical object we took some dimensions, and we'll call them something. So the first one we'll call the front, the second one is the front wheel arches, and following that is the third one, which is kind of the center with the highest point, the highest height of the actual item. After that is the rear wheel arches, and then you have the last end bit of the physical object from which we took dimensions. Now I'm showing you this because these slices, we're going to link them all together in order to create some nice curvatures, and these curvatures will flow from each one of those slices, which we call planes. So we have sketches in planes, and we link all these slices together. So as you can see here, this is an isometric view. We have the front plane, the front arches, the center, the rear arches, and the rear and the end. And these are actually what we were talking about in terms of sketches or planes on which we kind of draw our sketches. And our sketches in this case are just simple two-dimensional drawings, and we're going to look at the center one because that's the most complicated one, but really it's not that complicated. And in fact what it is just a two-dimensional shape that was drawn, and how I got to this was as simple as drawing a rectangle. I'll get rid of this first of all. I'll just show you how simple it is. So we go to the drawing tool, we choose a rectangle from a center point, click on that one, and we choose the center of this plane, and we just drag it out, and you can see that there's a rectangle that appears. And following that, what we want to do is we want to create a kind of rounded rectangle, because this object has kind of rounded edges towards it, and that's going to help us kind of create this effect of a smooth object without any sharp edges. So we just create a rounded corner rectangle in this case. Right, so from here we have the vague shape that we want, but the center bit, because of the windows of the car shape of the key fob, we want some kind of inset. We don't want it to be a rounded corner rectangle. We want some kind of inset, kind of representing the windows of the vehicle. So we cut off those top rounded edges and we just draw a straight line there. So this is how we get to this shape, and it's pretty much as simple as that. So now we have a cross section, and we can link, we can create a bunch of these cross sections and then just link them together using the loft tool. So right now we're looking at, you know, how the front arches are. The front arches are very simple. They're basically rounded edges, rectangles. I'll hide the rest of the sketches so that it doesn't confuse you too much. But as you can see, this is the front arch sketch, and it's basically a rounded corner rectangle. We have the dimensions of height of 10 and roughly a width of 30 here, and that's enough to define the subsection that we need for the front arches. So let's have a look at some of the other cross-section areas that we sampled from the real physical object. So let's look at the rear arches in this case. So as we select this, we'll kind of hide the other plane so that it doesn't cause too much confusion, and we'll focus on the rear arches. As you can see, the rear arches are very similar. In this case, it's 33 millimeters wide, 13 millimeters height, and it's going to be an aggregation of these different sketches that are going to join together to provide us with that three-dimensional object. So in order to merge all these cross sections together, we're going to use the loft tool. So on the toolbar you can see there's a button there. I've already got one, and as you can see, this loft tool is given some cross-section areas of sketches, and as long as you include them in your loft tool, it will link them all together with very smooth curves, and that's how you create your three-dimensional object essentially. So at this point what we have is a three-dimensional object, but the problem is that this object is a complete solid. So that means it's completely filled up, and what we want is kind of a shell. We want something that's hollow inside so that we can place our actual key fob inside. So to do that, you choose the shell tool, and from that one you choose hollow, and you choose the object that you want to hollow. In this case we already have one, so I'm just going to reuse that one and show you how I configured it. So in this case I just wanted it to have a 0.8 millimeter thickness to the wall, and the rest of the object should be shallow. and from that you just choose the object, which is the Tesla key holder in this case, and it just hollows it out for you. So another useful tool that Onshape provides you is the ability to have a section view. You choose a face and you can drag your mouse throughout the object and you can see what's inside of that object. So in this case, since we have the object hollow, you can see that there's nothing in there. However, if we disable the shell functionality and we do that again, so we do another section view, you will see that it contains stuff. It's actually not hollow. So this is what the shell function does, and that's how you can check it using the section view as well. Now the other thing is, while we have a hollow object, we need a way to insert our key fob into it. So we have to create a cutout from that object, and this is the cutout that we're talking about. It's basically another rounded corners rectangle, but it's in the middle of the plane of the object. And what we're going to do from this sketch is we're going to extrude it out. But what we're going to extrude is we're not going to add more material to our model. We're actually going to remove the material from our model. So for that we use the extrude tool, and we already have an extrude tool here. So you can see that there's the tab remove that's been selected, and I'm saying that I want to remove matter from that object. And what this does is it takes the shape of the sketch and extrudes, so it excavates basically material from that three-dimensional object, and that creates an opening at the bottom, and this is where our actual key fob goes. So if I didn't extrude this sketch, then I would have a hollow object, but basically no way to insert the key fob into it. So if I suppress that extrusion, you can see that it's all covered in a skin, in a surface skin, but there's no way to actually insert anything in there. So that's where that extrusion comes in handy. We just remove parts of a face from it, and that creates our entry for our key fob. And finally, last but not least, we need to create something that the keyring is going to hook into. So this is actually really simple. It's just two semicircles that are joined into the body of our model as a sketch at the center rear part of our model. And all we have to do once we have the sketch is just basically extrude it. So this time, instead of removing material, we're extruding, we're adding material, and we just need a depth of 10 millimeters or something like that. And this extrudes this structure as much as we want, or as little as we want, and this is ideal for inserting the keyring into. And that's pretty much it. This is our three-dimensional object done, and we can print this in TPU. So this is the final print, printing in TPU. Bear in mind the surface finish is not the best because I didn't dry out my TPU, and TPU is notorious for being hydrophilic, so it absorbs moisture. So for a first try, I'm quite happy with it. I think this will probably be something I will fine-tune and definitely use better filament further down the line, but I'm quite happy with it.